Hey everyone, this is Mascot Channel here, and today we're going to be going through maximum and minimum problems. So this is sort of a video on like mainly the practical applications of differentiation of differential calculus. So the example I give above is maximizing profit, revenue minus expenses, and for anyone who's done something similar like accounting, it's a bit of a juggling act having two variables like this. So I'm just going to go through, and the bottom of the two pictures you see at the bottom are sort of like the type of questions you might be asked relating to maximum and minimum problems. So I'm just going to go through some steps to help. So for example, first of all, you try to draw, if the question doesn't give you a diagram, first of all, you try to draw it with as few variables as possible to make it simple. And you try to make it, the next is try to make it in terms of one area. So for example, the diagram on the left, you have 2x and you have h. It's probably easier to make everything into, try to get everything into one variable, so either have everything in terms of h or everything in terms of x. Since there's a semicircle, you probably have the constant pi in your answer somewhere. And you have to use tips and tricks like the next is to use tips and tricks such as Pythagoras theorem, which is a squared plus b squared equals c squared. Although I believe most of you should know that already. Trigonometry, similar triangle, or other formulas. Like for example, the diagram on the right. You can see that I didn't put this up, but the question is asking, so at the point 4, 0 and the function y equals 2x squared, what is the coordinate on the function, so that the distance between the point on 2x squared and 4, 0 is the minimum. And you have to use things such as Pythagoras theorem to solve that length and derive it, derive it and get your answer. So you find the expression to help explain what you're trying to solve. You derive it, which we've gone through several times in this video. Equate it to 0 so that you have a solution. Afterwards you're going to need to reject certain solutions. So for example, if you're in practical applications that involve some things like time or distance, or time actually is the main example, like you can't have like negative time as a realistic answer, or like a negative distance. Like if I'm trying to optimize the area of a solid, such as a cylinder for like a can, then you can't have a negative distance, so you're gonna have to reject that sort of solution, and they'll come up every now and then. Then afterwards, when you differentiate the function, you need to check the nature of the turning points. That's what we've done before with the graphs. Check the endpoints as well to see, because sometimes the function will have a restriction domain. For example, like the diagram on the left, the question might say so like the perimeter has a fixed length, the whole perimeter has a fixed length. So that's you have to take that into account when trying to solve it. And also with the checking endpoints, you can see when the function is an absolute maxima or a minima. Then afterwards you have to obviously sketch the graph. Take into account things such as things like holes in the graphs or in the restricted domain, like the open and closed circle. And lastly, you just need to answer the actual question for whatever the task you need to do. And that'll be all.